All right. Okay, so I want you to think back to a time before calculators. I know that's hard to imagine, but all right. This kind of log, I would call this an easy log, right? We can evaluate this. We know how to turn a 5 into a 25 with an exponent. It's a 2, okay? But what if we are working with this as our problem instead? Okay? Can I take a 5, give it an exponent, and turn it into a 20? I mean, in theory, yes, it's possible, but is it a nice, even whole number? No, it's definitely not. So this is where these expanding condensing properties come in. So I want you to imagine taking this 20 and breaking it up into other factors, other numbers, like 2 and 10, or 4 and 5. In this case, because I've got a base 5, how about I do this as 5 times 4? And then I'm going to give the 5 its own log, give the 4 its own log. So then this is log base 5 of 5 plus log base 5 of 4. At this point, I'm getting much closer to being able to answer this question because we can evaluate this. What is that? That's a 1. And then we may be able to look this up in a table. Remember, we're back before calculators. We may be able to look this up in the table or use our slide rule to figure this out. Or we could guesstimate. What exponent would turn a 5 into a 4? Probably something just a little bit less than a 1. Like maybe a 0.9-ish or a 0.8-ish or something like that. So if you had to sort of guesstimate, you could kind of get yourself in the ballpark. This is what we're going to kind of see today, is this idea of taking something and breaking it down into its, like, some building blocks that are easier to work with. So if we look at 9i, at the start of the page, we have 3 givens, and I'm going to call these our building blocks, but I also want you to think of them as givens, kind of like givens in a proof. Like they're going to be very important. So there's log 2 is approximately 0.3, log 5 is approximately 0.7, and log 3 is approximately 0.48. Those are actually correct values if you type that into your calculator. This is log base 10 of 2, log base 10 of 5, and log base 10 of 3. So when we get these types of problems, what I want you to be thinking about is, okay, log 6, that's not one of these things. But could I get a 6 by using some one or more of these building blocks? Yeah. So let's take this 6. Couldn't I rewrite this as log 2 times 3? And then give the 2 its own log. So I would have log 2 plus log 3. Now I can go and do my substitution. I happen to know this is one of my building blocks. This is a 0.3. And then I happen to know that this is another one of my building blocks. I happen to know what that is. That's 0.48. So therefore my answer is 0.78. Yeah.
Couldn't you just look at that like after you see that's 2 times 3? Just that would be like you can see that like.
Well, here's the tricky part: is it switches operations.
Yeah.
Right. So you do have to kind of be careful about that. Did everyone follow his question? He was like, "Can't you just see that it's 2 times 3?" Yeah, you can, but you do have to remember that it's going to have that change of operation when it gets its own log and it turns into a plus, not a multiply. All right, I would venture to say there are 2 more building blocks that are more fundamental building blocks that I think would be helpful. What would log 1 be? What exponent turns a 10 into a 1? A 0. So this would be another building block that I could use. What about log 10? That would be a 1. That would be another building block I could use because my building blocks are all base 10. So think about how that can help you with like number 2 and number 3. Number 3 doesn't require any work. Number 3 is just 1. Number 2, what if you give the 1 and the 8 their own logs? So this would end up being log 1 minus log 8. Then rewrite the 8, because 8 would be 2 times 2 times 2, or 2 cubed. So this would be a 0 minus log of 2 cubed. Then this cube comes out front. So we're continuing to expand it, because I need to get it down to just the building block. The building block is log 2. So now this is minus 3 multiplied by log 2. Log 2 is a 0.3, so basically I've got a negative 3 multiplied by a 0.3. So this ends up being what, negative 0.9. And what's nice about these is that, like, because they're base 10, you actually could check your answers on your calculator. So what about 6? Just up here. So take a look at 6. Log 30. How can I get a 30?
3 times.
Or you could do log 5, log 3, log 2.
Yeah.
Okay, we've got 5 times 3 times 2 is one option. And then the other option is 3 times 10. Both of those should work. That's that idea, just like with proofs. That's my analogy with proofs. It's like sometimes you could do it with angle, side, angle. Sometimes you could do it with side, side, side. Doesn't matter as long as you have the right parts. So 6 can be done either way. And that's because this is a base 10 that allows you to use a 10. I don't know why this isn't allowing me to clear. Let's see. Let's try again. There it is. All right. So then, let's look at 19. 19 starts to get a little weird. Okay, this is like what? Like the millionth decimal place, if you count it out. Okay, so how are you supposed to use a 2, a 3, or a 5 to get this? We definitely want to use a 5. And then I want you to think about scientific notation. I want you to think about how many powers of 10. How many times did you divide the 5 by a power of 10? So let's see here. 1, 2, 3, 4, 5, 6 times. So if I was going to rewrite this, this would be log of 5 divided by 10 to the 6th. And so now I can give the 5 its own log, give the 10 to the 6th its own log, and I'll be able to evaluate this. So this will end up being log 5 minus log 10 to the 6th. All right, this was one of my building blocks. What was that, like 0.7? Okay, so that's a 0.7. This one is what exponent turns a 10 into 10 to the 6th? A 6. So this is 0.7 minus 6, so this is negative 5.3. So if you see really weird decimals, like right over here, write it as like 3 divided by powers of 10. This one's sort of already like that. Now, on the back, same idea. You're going to be using expanding and condensing with building blocks. It's one more step abstract on the back side. Look at what the building blocks are. We've got log base x of 2 equals an A. Then we've got log base x of 3 equals a B. And log base x of 5 equals a C. So when we do the substitution, we're not subbing in like a 0.7. We're subbing in like an A, a B, or a C. So all your answers are going to be things like A plus B, or 2B minus C, or something like that. So let's try 21. Okay, I've got an 8. I need to use a building block of either a 2, a 3, or a 5. I can rewrite an 8 as 2 cubed. So this would be log base x of 2 cubed. I then expand it. The 3 comes out front. This is 3 multiplied by log base x of 2. And this can be substituted out. That is my A. So the answer to this is 3A. The most common wrong answer to this would be A cubed. Just so you know. So be careful not to make that mistake. If you see radicals, make that a fraction exponent. What about this? What's that? Yeah, how about that? How about we write that as 3 to the negative 2? That might be the fastest way to do it. You could do it as log 1 minus log 9, but I think it'll be faster if you rewrite this as log base x 3 to the negative 2. Bring that negative 2 out front. So it'll be negative 2b. You got it. That is definitely your fastest approach to that problem. This one's fairly straightforward. This is going to be b minus c on that. And that doesn't necessarily require a whole lot of work. Do keep in mind that if it's base x, if you have log base x of x, that will equal 1. And if you have log base x of 1, that's a 0. Okay, those are sort of the basic ones that kind of are always there. And then in the last section, it's very similar to this. It's just they switched it around. It becomes just a little bit more abstract. We move the numbers and the variables into different spots just to see if you can still apply these properties in this way. So in this case, you're looking for a log A, and it equals a 2. A log B, and it equals a 3. A log C, and it equals a 5. Okay? Please, please, please tackle this over break. Do not forget all of this. We do come back, and pretty shortly after that, we have a quiz. So expanding, condensing.